Hello, 7th graders. In today's lesson, we are going to learn how to multiply rational numbers. Now, hopefully you remember from our previous notes that a rational number is any number that can be written as a ratio. This includes fractions and decimals, and they can be negative. All right, hopefully you've seen area models like this before. These are 10 by 10 blocks to represent multiplying decimals or fractions. So, because it's a 10 by 10, the denominator of our fraction is 10. So this represents 2 tenths times 9 tenths. Now we know when we multiply fractions, we multiply straight across. So 2 times 9 is 18, 10 times 10 is 100. Now what's cool is you can count the overlap here. There should be 18 squares that overlap out of 100 total. So this area model helps us visualize 2 tenths times 9 tenths. And 18 over 100 can be simplified by 2. This final answer would be 9 over 50. All right, the second one, the red is 3 tenths times, the blue has 5 rows highlighted. 3 times 5 is 15. 10 times 10 is 100. If you count the overlap, there should be 15 there out of 100 total. We can simplify this fraction by 5. Your final answer would be 3 over 20. All right, so for the rest of this page, we're going to explore what we learned with our integer rules, so multiplying positives and negatives, to see if it can still be applied to fractions and decimals. So just for this table, I'm going to let you use a calculator. You're going to pause the video, fill in the tables, and then we're going to talk about what we notice. All right, so hopefully you got that table filled in. Let's see what we notice. So first off, with integer rules, we're talking about what happens when you have a positive times a positive. What about a positive times a negative? And what about a negative times a negative? So if they're both positive, that's what we see all over here. Our product is positive. If you have one negative, that's what we see here. Our product is negative. And if you have two negatives, that's what we see here. Then your product is positive. Those two negatives canceled out. So yes, this is the same as our integer rules. We will be applying both our knowledge of multiplication of fractions and decimals with the integer rules we learned earlier this chapter. All right, so again, we have our key concept up here. This is just telling us that if I have a negative times a positive, my product is negative. And if I have two negatives, they cancel out, my product is positive. All right, we're going to multiply rational numbers the same way we multiplied integers. So our first step is to determine the number. Our second step is to determine the sign. And we're not going to use a calculator. So hopefully you remember how to stack and multiply decimals. If you don't, I'm going to walk you through it. So if you remember how to do this, you can go ahead and skip forward a little bit. Otherwise, here's what you do. You start at the bottom right. You first multiply both the right numbers. So 6 times 5 is 30. I write the 0, I carry the 3. So you're writing the number in the ones place, carrying the number in the tens place. Then we do 6 times 2. 6 times 2 is 12. We have to add the number we carried. So 12 plus 3 is 15. Because there's no more numbers to the left, I just write the 15. I don't have anywhere to carry anything to. All right, then we do the next number. We're done with the 6. So now we're going to multiply by the 3. We start with 3 times 5. Before we do that, we have to add a 0 as a placeholder here. So because we're on our second number, it should start 2 places over. All right, 3 times 5 is 15. I write the 5, I carry the 1. 3 times 2 is 6, plus 1 is 7. With these two numbers, I add them. So I should have 900, but 2 times 3 is 900. So notice what they wrote here. if there's one decimal place in one factor and one in another, 1 plus 1 is 2. There should be 2 decimal places in your answer. So this should be 9.00, or just 9. So we have our number. Now we determine the sign. I know a negative times a positive is a negative, so my answer should be negative 9. All right, before we multiply b, we need to make 1 3/4 into a improper fraction. That's where the top is bigger than the bottom. So if you forget how to do that, what you do is you do the whole number times the denominator and then plus the numerators. This is going to be 7/4. So then we're going to multiply 1/2 times 7/4. When we multiply fractions, we go straight across. This should be 7/8. Then we determine the sign. I know a negative times a negative is a positive. So my answer is just 7/8. Right. I want you to pause the video, try these 3 problems at the bottom, and then play it back to see if you got it right. All right, number 1, we had to stack 5.1 times 1.8. If we add those together, we should get 9.18. A negative times a positive is a negative. So this is negative 9 and 18/100. Fractions we multiply straight across. 4 times 2 is 8. 5 times 3 is 15. A negative times a negative is a positive, and this cannot be simplified. So that is your answer. This one you had to make improper fractions. So you should have 9/2 times 2 1/3 is 7/3. This is 63/6. This can be simplified by 3 to get 21/2. A positive times a negative is a negative, so your answer is negative 10.5. Or negative 21/2. You could leave it as an improper fraction. All right, in this next example, I'm going to show you guys some shortcuts to multiplying fractions. So notice there are 4 numbers here. What we need to do is we need to make 7 into 7/1. Then I want you to notice something. Notice we have 1/7 and 7/1. These are what we call reciprocals. 1/7 is just 7/1 flipped. If I multiply them, I get 7/7, which is 1. Anything times 1 is itself. They're also both negative. The 2 negatives are going to cancel out and be positive 1. So what we can do before even multiplying this is cancel out 1/7 and 7. Then we just have 4/5 times negative 1/2. One more shortcut I can show you. If you have 2 numbers on the top and the bottom that you know have the same factor, so like 2 goes into 4, I know they're both divisible by 2, I can simplify that before multiplying by dividing them both by 2. So 4/2 is the same as 2/1. So I can simplify this without multiplying to 2/5 times negative 1/1. Then we multiply straight across. 2 times negative 1 is negative 2. 5 times 1 is 5. So our answer is negative 2/5. Now it is easier if you cancel out the reciprocals. However, if you went ahead and multiplied this without simplifying, 4 times 1 is 4. 5 times 2 is 10. Hopefully you would then see, okay, this can be divided by 2 to get 2/5, and you would get the same answer. So you can use this shortcut way, or you can just multiply and then simplify. Either way, your answer should be negative 2/5. Okay, I want you to use that reciprocal rule to solve 4 and 5 at the bottom. All right, hopefully you paused the video. You're playing it back now to see if you got it right. So 2/3 and 3/2 are reciprocals. So I can change this to negative 1 times 7 and 7/8. And then there's not really any math we even have to do here because anything times 1 is itself. So this answer should be negative 7 and 7/8. All right, and then this one was a little trickier because you had to recognize that 0.1 is the same as 1/10. 1/10 and 10 are reciprocals. So we go like this, we carry the negative over to the hundreds, so then you have negative 7.02 times negative 100. The negatives actually cancel out. Your answer should be 702. All right, last example. Connecting to real life. To estimate the change in width of a wood tabletop during a year, you multiply the following quantities. Current width times change in moisture times dimensional change coefficient. You expect the moisture of a 36-inch wide black cherry tabletop to decrease 3.4%. Use the table to estimate the change in width. So what we need to do is we need to set up an equation, which they actually did for us right here. We know the change equals the width times the moisture content times the dimensional change coefficient. Then we're just plugging in information. So they told us the width up here, it's 36 inches wide. The percent change in moisture content is this negative 3.4%. Because it's a decrease, we represent it with a negative. And then the dimensional change coefficient, we need to look for black cherry. That one's right there. Okay, then we just multiply all three of these together. And I actually recognize, I know 1/4 is 0.25. So this 0.0025 is 1/400. I know 1/4 of 36 is 9. So 1/400th of 36 should be 0.09. Then we just need to multiply that by negative 3.4. If we stack that up, 3.4 times 0.09, 9 times 4 is 36, 9 times 3 is 27, plus 3 is 30. There are 1, 2, 3 digits after the decimal, so there should be 3 digits after the decimal. This should be 0.306, and then a negative times a positive is a negative. So this should be negative 0.306, and then down here it says the answer is negative, which means the width of the tabletop will decrease by about 0.306 of an inch. All right, we're going to skip this one at the bottom. You can submit your notes for today. This was lesson 2.4. And make sure you check Canvas to see the rest of your assignment.